Okay. Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing statistics and mathematics at University of Toronto. Today we'll be going over some commonly asked mathematics questions at both the high school level and college levels. And if you need some homework help or tutoring, check out the links in the description below. Okay, so now let's start our session. Okay, so the first question is asking us to, I'll write it down here, to take the derivative of tangent x, right? Yep. So before jumping to this question, I would first like to talk two things first. So the first thing is, we know that tangent x can be written as sine x over cosine x. Yeah. So that's the first thing I want to mention. And the second thing is that the rule of quotient. What's the quotient root in derivative? So it can be represented by d dx. If we have a function fx over gx, this will be equal to gx times the derivative of fx minus fx times the derivative of gx over gx squared. Yep. So by knowing these two things, let's go to our question. So like I just mentioned, instead of solving derivative of the derivative of sine x over cosine x, right? So it can be written like this. Sine x over cosine x. These two parts are equal, right? And notice that the right-hand side of the equation involves getting the derivative of quotient of the expression. Since there's a function over another function, which means sine x over cosine x, so now we need to apply the quotient rule. And yeah, recalling the quotient rule follows this. So d dx tangent x is actually equal to, you know what, just forget about that for a second. I'll just deal with the right hand side first. So the right hand side, d dx sine x cosine x, this is equal to cosine x d dx times sine x minus sine x d dx times cosine x over cosine x squared, right? So it is known that the derivative of sine x is cosine x. I'll write that down. We know the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Hence, we simplify the above equation we have so this is going to be cosine x times cosine x minus sine x times negative sine x over cosine x squared. Right. So we're combining the numerator, so we got cosine x squared plus sine x squared over cosine x squared. Right. And this can also be written as cosine squared plus sine squared over cosine x. Recalling that we can substituting in the Pythagorean identity, which is given by 1 is equal to sine x squared plus cosine x squared. And the identity of secant, which is 1 over cosine x, is equal to secant x. By substituting this, we will get derivative dx sine x over cosine x is equal to 1 over cosine x squared, which means we just need to substitute this part by secant x, which is just equal to secant x squared. Right. Oops. So hence the derivative of the function tangent x is secant x. Secant x squared. Right. So let's recap what we covered in this question. So the first thing is we need to know that tangent is equal to sine x over cosine x. And then we need to apply the quotient rule, which is given by this part. And don't forget, for the denominator part, there's a exponent of 2. And also, remember the derivative of sine is cosine x, and the derivative of cosine x is negative sine x. And for the last part, we're calling the Pythagorean identity. So sine x squared plus cosine x squared is equal to 1. And the identity for secant, so secant x is equal to 1 over cosine x. Yep. So that's what we go for this question. Let's leave a comment there. Right. Good. Well done.